Alright, so today we're going to be talking about segments and triangles. This is important because it's going to be heavy on vocabulary, and in the future we're going to be talking about different centers in triangles made by these segments. So it's very important that you actually are familiar with the vocabulary, make sure you have the vocabulary written down, and begin studying this vocabulary, because I will expect you to know these definitions and be able to apply them in problems in the future. Alright, so we have a couple of vocabulary terms like I've said. First of these is a perpendicular bisector. We've been using this over and over and over again. Remember, a perpendicular bisector is, if I have a line, okay, a perpendicular bisector will cut this line in half at a right angle. So there and there. Okay? Now, equidistant. Let's say that I have a point A and a point B. Okay, they would both be equidistant to their midpoint M, meaning they have the same distance or equal distance. Now, concurrent, we briefly mentioned this, but concurrent happens when I have multiple lines intersecting. Now, this right here is not concurrent because it's only two lines. It's not a big deal when two lines intersect. It's like, yay, it happens all the time. But the minute that I have three or even more lines all meeting at the same point, that's what we call concurrent. And that is a big deal because that doesn't happen very often, okay? We're going to talk about the concurrent lines in a triangle when we talk about the orthocenter, incenter, circumcenter, and centroid. So that will be coming up in the next few slides. Now, point of concurrency. It is as simple as it sounds. The point of concurrency is just this intersection, this point right here where all the lines meet is the point of concurrency. Okay, so it is as simple as that. Now, the perpendicular bisector theorem, it says, in a plane, if a point is on the perpendicular bisector of a segment, then it is blank from the endpoints of the segment. Okay, remember we talked about this with the law of reflection. If I have a perpendicular bisector and A and B, that line is being bisected, then AC must be equal to CB. Okay, so what we have here is equidistant. Oops. So if CP is the perpendicular bisector of AB, then CA equals CB. Now, the converse of this is also true. So if I have a point, say D, and that point is equidistant to the endpoints of a segment, then point D lies on the perpendicular bisector. So in the case of the picture, we know that AD and DB are congruent, so D lies on the perpendicular bisector of line AB. I abbreviated perpendicular here. Remember, perpendicular symbol is just upside down T. Alright, so looking here, if I know that line DC is the perpendicular bisector of AB, then AD must be congruent to DB. That distance here. So we know that to be true by the law of reflection. We know that also to be true by what we just learned, the perpendicular bisector theorem. Now, if you take a look here, I can actually prove that triangle ADC is congruent to triangle BDC. Now, I have a couple things. First off, these are right angles. So this is the hypotenuse, while this is the leg. So I can prove these two triangles congruent by HL. I could also say by the reflexive property, DC is congruent to DC. So that would mean I have side, side, side is congruent to side, side, side. So there we are. I can either prove this by HL or side, side, side. Okay, a couple more definitions. First off, angle bisector is an angle, it cuts an angle in half into two equal pieces. Alright, I'm going to slide this down and then draw a triangle real quick. Alright, so the medians of a triangle, okay? The median is going to be you're going to find the midpoint for each side. So let's say approximately here. Now this midpoint here, I need to connect to the opposite vertex. Alright, so find the midpoint here, do the same. And the midpoint of this side goes through that vertex. There we go. So those three green lines that I've drawn are the medians of this triangle. And you'll notice that they are concurrent, meaning that they meet at one point. Okay, that's going to be important for our next lesson when we talk about centroids and orthocenters. Alright, so let's get another set of lines. Here's a triangle, and this time we're talking about the altitude. Now, an altitude is a perpendicular line from one vertex to one side. Now, it's not necessarily going to cut it in half. It's just the altitude. So this right here is an altitude because it goes from one vertex and it meets it at a perpendicular line. The altitude is the shortest distance from the vertex to the opposite line. Okay, do you remember that the shortest distance from a point to a line is the perpendicular line? So draw the next altitude here. Right there looks about right angle, and from this vertex down, that is your right angle. Okay, and if you take a look, you'll actually see that they are also concurrent as well. Okay, so again, this is going to be very important when we talk in our next lesson. Alright, so now we need to match the term to the picture. You're given median, altitude, angle bisector, and perpendicular bisector. What I'd like for you to do is go ahead and pause the video, and under each triangle, pick which one of these four belongs to that name. They'll each be used one time. So go ahead and take a pause. Hey guys, I know you're diligently working on this problem, but I want to take a minute and show you one of my awesome bobbleheads. This is Iron Man from the Avengers, also from Iron Man 1, 2, and 3. I have to tell you, he is my absolute favorite Avenger. You know, you have your favorites too. This is my favorite, so remember a little tidbit that I might ask you about tomorrow. Alright, so as we recall, a perpendicular line, it does not cut the triangle side in half, must be the altitude. Alright, now this is a perpendicular line that also cuts the side of the triangle in half, therefore it is our perpendicular bisector. Alright, this one on the bottom right hand corner, you'll notice that it actually cuts the angle in half, so it's going to be my angle bisector. And this line right here cuts the side of the triangle in half, but not at a right angle, so it is our median. Alright, so using the diagram below and the given information, decide in each case whether AD is the perpendicular bisector, angle bisector, median, or the altitude of ABC. So for problem number 1, we're given that DB equals DC. Okay, we don't know anything about the angle, so this only makes a median. Okay? So that's it for problem number 1. Now problem number 2 is a completely different problem. So erase your markings and start over. Now it says angle BAD here and CAD here are congruent. That would make the angle bisector. Now we have that DB equals DC, so on number 3 we're starting a new problem. Erase your markings. AD is perpendicular to BC. Now, it cuts it in half and it makes a right angle, so it is a perpendicular bisector. Now, the perpendicular bisector can go through the vertex. I know that on our previous problem, it did not. That's because of the obtuse triangle that we have here. Okay, it will go through the vertex and equilateral, and one of them will go through in the isosceles triangle. So perpendicular bisectors, it can go through the vertex, but not always. Alright, and then last but not least, we have that AD is perpendicular to BC. We don't know if it bisects BC, so that would strictly be our altitude. Alright, that's it for today. This video is under 10 minutes. Woot woot. I will see you guys later.